Hello again. This is the final question from Chapter 10's worksheet, talking about confidence intervals with paired or independent samples. So if you're watching the other video about how to complete just the t-test with the one sample t-test, like from Chapter 9, you follow the same method when it comes to doing t-tests with independent and paired. What's mostly important is you got to pay attention to this error term. So what I have right here is that, so this question is asking about confidence intervals. And so what you need to pay attention to is this error term right here. So for paired test, this is S sub D bar, whereas over here, this is the error term for independent samples. So why they're here is that you've got two different equations for confidence intervals if you've got a paired or an independent sample. So the last video talking about paired versus identifying if it's independent or paired, that's why it's really important to figure out if it's paired or not, to know which kind of equation to use. So first and foremost, you got to figure out if you're dealing with a paired or an independent test. If you are, then there's a different set of equations to find a t-test for paired. There's a different one to find a t for an independent. The same thing applies for confidence intervals. There's a different kind of thing. And really what's different is some of the nomenclature. So if you got paired, you've got an X bar over a Y bar, whereas over here you've got a sample and a sample. So that might be kind of heads up to figure out if you've got two different samples versus, you got two different samples versus two different averages from the same kind of vibe. So that's somewhat helpful. Here is a different error term, and so you just got to follow along for the algebra to make sure which error term you're looking at. And again, this error term is sort of a grouped error term for the paired sample. So if you really want to get lost in the weeds here for 1 second, this is a different error term. Why is this different? Because if there's a pairing of one average score and the other average score, they share error. So let's talk about if it's a pre and post test kind of situation. If it's pre-post test situation, what that means is that, say I'm in this pre-post test. Well, my error is involved with my pre-test average, and it's the same error that's involved with my post-test average. Whereas here, if I got two different unique samples, I've got 24 people here, and I've got another 24 people, or I got 10 people here, I got another 10. There is no shared error here. That's why we got different error terms here. This is just one error term, this is two different error terms. So that's maybe somewhat helpful for you to understand why we need to do these two different equations. Okay, so for the setup for this question for the worksheet, so we've got 24 fifth graders, and what are they doing? They're given fishing reels. 12 were tested individually, 12 were tested tested individually. What does that mean? The number of yards of line reeled in 10 seconds was recorded for each person. The other group was tested together under conditions of competition. The one who reeled in the most line got to keep the reel. All right, so again, probably best to imagine the situation to try to help what you're talking about. So you got 12 fifth graders, and I said, here's a line. How fast can you reel this line in 10 seconds? Great. Then I got another 12, and I treat them the exact same way, but then I say, you know what? Whoever reels the most gets to keep the reel. So now we've got competition. Now we've got some sort of reinforcement here. So you can imagine what the hypothesis is here is that if you're telling me that I have a chance at winning the fishing reel, I'm probably going to reel in more than if I just were like, oh, here, 10 seconds reel. You're like, oh, okay, whatever. Here, it's more along the lines of, hey, if I get to keep the reel, I want to try harder. And as you can see, these are the averages. So for the independent, we got 16 yards in 10 seconds, whereas 24 yards in 10 seconds for the group. So you can see there's a difference already between the two different conditions. And the question's asking for a 99% confidence interval. So what does this mean? We got to figure out if it's a paired and independent sample. So if it's paired, we use this. If it's independent, we use this. Well, now you got to figure out. So is there one score in this group of 12 kids that's specifically matched to a particular score in this group? Like, is there any, like, are these different people? Yes, they're different people. So we got 24 different people. Is this one, like, let's just say this is participant A, and this is participant, I don't know what letter 13 is. Let's just say it's M. This is participant M. Is A and M linked? Is B and N linked somehow? No, there is no linking between these two people. So we do have an independent design here. So what does this mean? We're using this set of equations. So let's go on doing this. So let's look at this very first one. So if we've got the lower limit right here equals 16 minus 24, where am I getting that? So we've got the x bar of group 1 versus the x bar of group 2, so that's where we got these two from. Subtract my t value. Oh crap, where do I get this t value? All right, so where are we gonna get our t value? Well, where we always get our t values, we go to our t distribution. So what's going on with our t distribution? Well, we know we're dealing with a 99% confidence interval. So what does that mean? You stick up here at 99%. What do we need to know? We need to know degrees of freedom. You're like, okay, so what's going on with degrees of freedom? Well, we know if we're dealing with an independent, our degrees of freedom for a independent two sample test, we've got an N1 plus N2 minus 2. That's our degrees of freedom. So how many people were in N1? Well, we got 12 people there, plus 12 people here, minus 2. So we got 24 total, minus 2. Our degrees of freedom are 22. So now that we got our degrees of freedom, we go over here, we go 99. Ooh, there we go, 99. So we get this our confidence interval, we want a 99, and we got to go down to 22. So right there's 22. We go all the way over here. What do we got? 2.819. 2.819. So that's our t value. So that's how we got our t. But then we got to do something else. We got to do this. And so, unfortunately, I didn't mark it very well on your worksheet, but that's that 2.25 in your worksheet. So we've got that 2.25 was given to you. So as soon as we figure out what this value is, all we're really doing is taking this difference. If you want to figure out what this difference is, it's 8. And we're adding and or subtracting whatever this number is. So if you just did some math real quick, what is that number? Well, that number equals what? You did the math right here, the 2.8 times 2.25, you end up getting a number of 6.34275. All right, so what are we doing here? We're taking that number and we're adding it and subtracting it from 8. So if you just if you subtract it, you get a lower limit of 8 minus 6.3 whatever, you end up getting 1,65725. So that's your lower limit. Now your upper limit is that you got to take that and you add 16 or 6 from it. So you're going to know you're looking for something that's going to be around a 14, and what you actually get is 14,34275. So what does that tell us? That tells us what? So I want you to be able to figure out how to interpret this. So you've got an upper and lower real limit of what? Of the difference between these two groups. So what does that mean? I'm 99% confident that the real difference between people who think they're doing it for nothing versus the people who are thinking they're going to win a fishing reel, that real difference lies between 1.65 and 14.34. So what's noteworthy about this is that 99% confidence, like 1.6 yards, that's not huge, honestly. All right, that's not a huge significant difference. If we were going to do the significance, it would come out as significant. But I want you, that's how you interpret this confidence interval. You say with 99% confident, the true difference between these two groups, because of how they're treated, is 1.65 yards to 14.34 yards. So because this is only based off of 24 people. If we did it against all people were an independent, or theoretically half people would have to be independent. So half the people in the world were independent, half the people are in a group. I'm 99% confident this is what the difference between those two groups is going to fall within these two numbers. That's what that 99% confidence interval is telling us. What is noteworthy is that if these sets of numbers, like again, we're going back to what we're no longer going to be doing, the SPSS stuff, but if we were looking at SPSS stuff, it'll give us a confidence interval. I am 99 right now. This is a 99% confidence interval, but 0 is not in this confidence interval. So what does that mean? I'm 99% confidence. There's always going to be a difference. There's always going to be some sort of numerical difference between these two groups. So if there's always going to be a difference, then I know they're statistically significantly different. if a 0 was in here, you say, how the hell would a 0 be in here? Sometimes if I wanted, a 99.9% confidence interval, I can get a negative 2 point. Let's go to a different. So let's say if I was, just for giggles, I don't know if this is real, but if I went to a 99% confidence and I ended up with a negative 0.5 to positive 19, 0 is in this confidence interval. You start thinking, well, how the hell is 0 in this confidence interval? Well, think of a number line. So if I start at a negative 0.5 and go all the way up to a positive 19, here's 0. Let's just see, what is that, 10? No, let's see, that's 10. So there's a 10, but the 0.5 is over here. But so 0 is in this range. So if 0 is in this range, then I don't have a significant value here. But here I've got 1 to 14, so 0 is not in this range. So that's telling me I know I've got a significant difference, at least at a 99% confidence interval. I might not be at a 99% confidence interval. So that changes based off of your confidence. Typically, most confidence intervals are 95%. But for this one, I just wanted to see if you can calculate it using the 99 and figuring out how to use the t-distribution. All right, so I think that's it. Got any questions, let me know. Thanks.